Good morning, students. Let us move to the model number 5, symmetrical fault analysis. First, tell me, what is a fault analysis? The different types of the faults, symmetrical faults and symmetrical faults. In this chapter, symmetrical fault analysis, it means a balanced system, all three phases. Here, abnormal system behavior under conditions symmetrical short circuited. Abnormal means the fault conditions, behavior in the system, abnormal system behavior under a condition of symmetrical short circuited. It means short circuited with the line to line, double line to ground, or a single line to ground, caused in the system accidentally through the insulation failure of the equipment. The system must be protected against flow of heavy short circuit current by disconnecting a fault part of the system by means of short circuit breaker operated by the protecting relay. It means short circuited between the line to ground. The system must be protected against a flow of heavy short circuit current. It means disconnect the fault part F of the system. It means 3 times of suppose 5 amps current in single phase. The fault means into 3 times 15 amps. More than 15 amps the circuit will be faulted. It means short circuit will be operated by the protecting relay. Through the relay the circuit breaker will be tripped. The majority of the system faults are not a three-phase faults but fault involving only one line to ground or double line to ground. The major fault in the system, 70% fault in the system, that line to ground fault or double line to ground fault. Through the symmetrical faults are the rear. The symmetrical faults through the endless must be protected. It means symmetrical, the balance system, the system must be protected. In the modern large interconnected power in the system, heavy currents flowing during the fault must be interrupted but before the steady state conditions are established. The constant condition, the fault occurring in the system, modern large interconnected power system, heavy currents flowing during the fault must be interrupted. Why the interrupted? It means the fault current is, heavy fault current is moving in the circuit. Okay, the next first one, transient on the transmission line. It means a resistance inductance through the fault. That is, let us consider short circuit transient in the transmission. Certain simplified assumption made. What are the assumption made? Suppose a transient in the transmission line. First assumption, the line in the fed from the constant voltage source. The line should be constant voltage source. Short circuit takes place when the line is unloaded. Whenever the short circuit takes place, the line is unloaded. Without loading, unloaded. The line capacitance is negligible. The line can be represented by lumped. It be assumed the negligible lumped RL series circuit. It is RL series circuit. Short circuit assumed to take place t equal to 0. Initially t equal to 0. The parameter alpha controls the instant of the light wave. The short circuit occurs if is known from short circuit theory. The current after the short circuit is composed. Okay, that is I equal to ISC, short circuit current, steady state current, that is root 2 V by Z sin omega t alpha minus theta. What is Z? R plus omega L square. But here theta equal to tan inverse B by A. What is B here? Omega L by R. This is B part, this is A part, A plus JX. Same thing, B by A, tan inverse omega L by R. Here I take transient current, the IS is 0, E R by L T, exponential R by L T, root 2 V Z sin theta alpha. Like this waveform depends on the equations. Right now the equations. Here the sinusoidal steady state current is called symmetrical short circuit current, and the unidirectional current, which is caused the total short circuit current to be unsymmetrical till the transient decays. It means the transient decays, the current will be decaying because of unsymmetrical till the transient decays. The maximum momentary short circuit current IMM correspond to the first peak if decaying of the transient current in this short time neglected. It is IMM. It means a transient decaying maximum momentary current, that is root 2 V by Z. Root 2 is a peak. The peak to peak value, this is root 2 V Z sin theta minus alpha plus root 2 V Z. Theta equal to 90 degree. I am momentary, maximum momentary current root 2 V Z cos alpha plus root 2 V Z. Okay, this has maximum possible value for alpha is 0, short circuit occurring when the voltage wave is going through the 0. It means alpha is 0, short circuit occurring when the voltage wave is 0. I maximum possible 2 into root 2 V by Z, twice of the maximum symmetrical short circuit current, doubling effect. Thank you. Remaining the next video lecture. Thank you.